Alright, Unit 3, Lesson 8 is going to look a little different than the others because I'm going to give you some basic instruction here about what all this stuff means, and then I'm actually going to walk you through the homework problems inside of my math lab, so you'll actually get to see me working them out and using the software, so that could be helpful. I know that you see there's a lot of letters going on here in this objective, and I'm going to clarify what all of these things mean. What we are going to do in this lesson is we're going to graph quadratic functions of the form f of x equals a times x minus h, all of that squared, plus k. Now I want you to keep something in mind here. All of these letters just are representing numbers we're not plugging in yet, and they each tell us something different. So this is where I know this can get a little complicated, but I want to help clear this up. So first of all, let's think about some basic examples maybe that don't have all that stuff in there. Of course, you know what this looks like. If I say f of x equals x squared, okay, that's just a basic parabola that opens up, right? If I were to, try to draw a real rough sketch of its graph, all right, it's gonna. Okay, pretend that went through 0, 0. That was a terrible rough sketch. I apologize. Okay, it's going to look like that, right? Oh boy, that's bad. Alright, anyway, that's your basic parabola. Well, when we start adding in these a's and h's and k's, it's just going to move this thing around. Notice that I could write this as 1 times x minus 0 squared plus 0. Now, notice what I've done is I've taken this basic parabola, y equals x squared, and I've written it in this format where a is equal to 1, h is equal to 0, and k is equal to 0. What these things mean, they tell you specifically how to move it. Okay, the a, let's start with the a. A is the multiplier. And if you think about your basic form of any quadratic equation, you've got ax squared plus bx plus c. A is going to tell us the shape of the parabola. If a is greater than 1, so let's see here, let me write this out. If a is greater than 1, then, I'm going to use arrows here, then the parabola is narrower than this standard parabola I have over here. Okay, assume that's a pretty picture of y equals x squared. I know it's not. So what that means is if a is greater than 1, let me come in here and draw over my terrible, ugly parabola and draw a different one. You're going to have a parabola that looks something like that. It's going to be narrower. I'll put that as, that's green. I should have written it in green, then it would have been clearer. So if the number that's in front of the x squared, the number out front there, is a number larger than 1, you've got a narrower parabola. It makes it get bigger quicker. What if a is less than 1? You can probably guess it. It's the opposite, right? So if a is less than 1, now, actually I shouldn't even say that. That's not even true. I should say the absolute value. Let me go back and fix this. Absolute value. I need to put absolute values on here because I haven't even talked about negative and positive yet. If the absolute value of a is greater than 1, okay, so if it's smaller than negative 1 or bigger than positive 1, that makes it narrower. If the absolute value of a is less than 1, then that makes the parabola wider. So if I come over here, it's going to look something like this. So if you've got a number out there in front of x squared that's a fraction, basically, between 0 and 1, then that's going to make your parabola wider. Now, if a itself, just period, if a is less than 0, in other words, if a is negative, if you have a negative number in front of your x squared, then that flips the parabola. The parabola opens down. So it would be coming down here like this. Okay, again, terrible drawings, I apologize. So there's a bunch of information that a tells us just by itself. We look at a, we look at that number in front of the parentheses, and we know whether it's wider, narrower, or whether it opens up or opens down. So if a is positive, the parabola is going to open up. If a is negative, it's going to open down. If a is between 0 and 1, in size, then the parabola is getting wider, and if a is bigger than 1, then the parabola is getting narrower. Okay, so that's A. A tells us the most information. It can tell us the most different things. Now let's look at H and K. Let me come down. I'm going to try to squeeze this. H and K just tell us how the vertex is moving. H tells us side-to-side movement, and K tells us up and down. So let me give you an example to hopefully make it make sense. So like we said a minute ago, if you've got f of x equals x squared, well, the vertex is just at 0, 0. That's where it is. It hasn't moved. Well, what if I come in and I give you f of x is equal to, let's say, x minus 1 squared plus 6. Well, this tells me that the vertex is at 1, 6. Okay, because in this format, when I say this format, I'm going to highlight it way up here at the top of the screen. I'm talking about this. If I've got an equation that's written in this format, then my vertex is located at HK. That's the great thing about this format. Just by looking at it, I can tell, okay, the vertex has moved this many side to side and this many up and down. So I just took my H, which was 1, my K, which was 6, and that's my vertex. Now notice, I want you, this is something that gets people. H is not negative 1. All right? Even though there is a, I'm going to highlight it here, even though there is a negative sign right there, H is not negative 1 because that's a minus sign that's in the formula. It's x minus H. Okay, so for instance, let's give you another example. Let's say we had, now I'm going to give you the whole kit and caboodle here, and then we're going to go look at examples on the, why won't it cooperate? There we go. Examples on the homework to make it make sense. If I gave you f of x is equal to negative 2 times x plus 3 squared plus 2, we'll say. All right, let's think about everything we know about this graph. First of all, this A out front. Let's highlight this. It's negative, which tells me that the parabola opens down, and it's a 2, which tells me that the parabola is narrower. So, if I'm just going to rough sketch this, okay? I'm going to a rough sketch. Let's figure out where our vertex is. Well, remember the formula is x minus h squared plus k, and my vertex is located at hk. Well, so what is h and k in this case? H you have to think about with the opposite sign. It's the one that confuses people again, because there's a minus sign here in the formula, but if I look at my equation, it's x plus 3. Well, so if it's x minus h, then h must be a negative 3, because minus a negative would make that a plus. So my vertex is at negative 3, and then k is just exactly what it looks like. It's 2. So really, if you can just remember to change the sign on the number in the parentheses and keep the sign on the one on the end, then you're good. So we've got negative 3, 2. So if I come over here, again, this is going to be a rough sketch. I'm going to come over here about here-ish. That's probably close enough. What? Really? Negative 3, 2. Not negative 2. I'm sorry. Negative 3, positive 2. My bad. So my vertex is about there. It's a parabola opening down, and it's narrower than normal, so it's going to be kind of like that. Now, again, that's a rough sketch. You're about to see much better graphs when we look at the homework. But I just wanted to give you a chance to see these formulas before I go and show you the homework. Okay, so let's remember what these things mean. Back to the formula. A tells me the shape of the graph. Is it wider or narrower? Does it open up or down? And then H and K tell me how the vertex has moved. H tells me side to side. K tells me up and down. Okay. Well, let's see. Let me get rid of this, and let's look at this screen. I've got the homework pulled up here on preview screen. So this first problem, f of x equals x squared minus 1. Now, this doesn't seem to be in that format, but Really, it just means there's no h. In fact, I'll tell you what, let me bring this back into OneNote and let me write it real quick, just this one example so we are clear here. X squared minus 1. Come down here and give myself some room. So our problem is f of x equals x squared minus 1. So this one doesn't really have an h. Remember, I could think of this as x minus 0. H is just 0. If it's not there, it must be 0. Minus 1. And of course, a, we don't write it out here, but it's understood that it's a 1. Right? So we've got a is 1, h is 0, k is negative 1. So think about what this is doing. What this is doing is, and let's come back and focus on this original version here. All this is doing is you're taking y equals x squared and shifting it down 1. That's all that's happened here. Nothing else has changed. The shape didn't change because a is still 1, and I didn't move it side to side. H is still 0. I didn't add anything inside of the parentheses. There's no parentheses here with the exponent. So all I've done is I've moved it down 1. Okay, so now let me go back to the homework and show you what we're going to do with this. So notice there's several instructions here. Sketch the graph of the quadratic function and the axis of symmetry. So first let's talk about the quadratic. Let me pull it up a little larger here. You know you can always click on this magnifying glass here and make it larger. I'm going to go medium. Okay, so if you're looking at what tool should I use, well, we're trying to graph a quadratic equation here, so you want to use this tool here, the vertical parabola tool. We're not doing any horizontal parabolas. Now you want to start by finding the vertex. That's the easiest. That's how it's expecting you to graph. Notice up here in the directions it says click the graph to plot the vertex of your parabola. So it's expecting you to plot the vertex first. Well, like I said, all we did is we moved down 1. So I'm going to click there. Now I've plotted the vertex, and now notice it says click the graph to plot a point on your parabola, any point. And notice as I move my cursor, it's going to change the shape of the parabola. I only have to give it one more point and it will graph the whole parabola for me. Now keep in mind the shape didn't change here because it's just x squared. A is equal to 1. So one way you can do this is just plug in any other value of x and see what you get. But hopefully by now you know in a standard parabola, if the shape hasn't changed, you would go up 1 and over 1 to get to your next point. But you can check it by plugging in. If you plug in x equals 1 into that equation, 1 squared is 1, minus 1 is 0. So I'd be at 1, 0. Okay? So, there we go. We've got our parabola graphed. Now that's just the parabola. Okay? Now that's the first part of it. Okay, now it says sketch the graph of the quadratic function and the axis of symmetry. What is the axis of symmetry? The axis of symmetry is just a vertical line that cuts the parabola in half. And it's really easy to figure. It's basically where the line that creates a mirror image. Well, let me bring up the big graph again. Let me get it on medium. So where would this be cut in half? Well, right down the middle, right? So I need to graph that. So what you want to do now to graph the axis of symmetry is choose the line tool and just pick 2 points here that make it go right through the vertex. And then we're going to save. Okay. Alright, now I have graphed the quadratic function and the axis of symmetry. At this point I need to check my answer, which is off of the screen. You can't really see it, but I will check my answer. Sorry, that's not correct. I'm so glad that I did that because I did not read the directions. Okay, I knew that there was supposed to be something dashed. This is why you read the directions, and I didn't. Notice that the graph of the function should be solid, the graph of the axis of symmetry should be dashed. So, okay, and it does tell you that right here. Use the graphing tool to graph the function as a solid curve and the axis of symmetry as a dashed line. So let me come back in here and fix that, since apparently I was not very intelligent the first time. Click on, now I've clicked on it, I've selected it. Come down here, notice I can come over here and make it dashed by clicking on the dashed line. Now it is dashed. I'll save, and now it will say, good job. Okay, so you're going to have to make sure that you make the axis of symmetry a dashed line. Now there's multiple parts to each question. The vertex is, it wants an ordered pair. Well, where is the vertex? It's at 0, -1. If you have graphed the equation already, finding the vertex should be really easy. You can hit check answer. Oh, that's very fantastic. Now it wants an equation for the axis of symmetry. I want you to think about this. The axis of symmetry is a vertical line. It's going to be a vertical line that goes through the vertex. Anytime you have a vertical line, it's always going to be x equals something. Vertical lines are x equals, not y equals, because they're vertical. Okay, so what does x equal? Well, it equals 0. It has to go through this point, right? It goes through the vertex. So anytime for your equation of your axis of symmetry, all you're going to do is say x equals whatever the x value of the vertex is. Good job. Okay, that one was fairly straightforward. Let's get to one that has a little bit more involved. Now this one, instead of moving up and down, notice what's this one doing? It's moving side to side. It's got x minus 3 inside the parentheses. So if I go to graph this, goodness, this one, I don't know why they gave you such a huge plot here, so it makes it impossible to graph. But anyway, vertical parabola tool. Okay, we're going to make our vertex first. Now think, what is my vertex doing? It's x minus 3. So remember, when the number is inside the parentheses, you have to think backwards of the sign. So this is actually moving the vertex 3 to the right. So I'm going to click here. The shape has not changed. All right, there's no a out there, so it's just 1. So that means I'll just go up 1 over 1 to make the rest of my parabola. Okay, now I have graphed the parabola. I need to graph the axis of symmetry, so I'm going to do the line tool, and I'm going to go ahead and make it dashed now while I'm thinking about it. And we're going to make it right through the vertex. Remember, you have to choose 2 points to make a line. So make sure you make a vertical line through the vertex. I'm going to click save on that, and then I'm going to check my answer. Yay, that was very nice of me. The vertex is, now where is the vertex? Well, we said it moved 3 to the right. So it moved over to positive 3. The y value did not change. So, well, hello. How about we put a 0 first? The y value is still 0. Enter. And then the axis of symmetry. Again, it's an x equals line because it's a vertical line, and it goes through the vertex, which is at 3. X equals 3 is my axis of symmetry. Okay, let's skip up here to, let's see, I think I'm going to, yeah, that one moves both, but I want to get up here to one that has all parts involved in it. Let me get to one that's slightly more. Okay, here we go. This will be a good one. All right, now this has a lot going on. So we got f of x equals -5 times x plus 1 squared plus 3. So when I go to graph this, make this medium. Let's see if I maximize it. I think it, yeah, that's why I don't maximize it. It makes it all distorted. So medium is big enough. The first thing you're going to have to figure out is where is your vertex. So look at here. Look at your h and k. I've got plus 1 in parentheses. Remember, this is my side-to-side movement. This tells me the vertex moved 1 to the left, right? Not to the right, because the sign is backwards. So it's because it's x minus h. So h is actually a -1. So my vertex is at -1, positive 3, because this plus 3 out here tells me it went up 3. So when I go to graph this, I'm going to put my vertex at -1, positive 3. Now, I have to look at the a here, because I've got an a that's not equal to 1. My a is -5. That tells me 2 things. It tells me the parabola opens down because it's negative. It also tells me the parabola is going to be much narrower because obviously it's a 5 in there. Right? Okay, so probably the easiest thing to do here is pick x equals 0. If you pick x equals 0, it's going to give you some easy math to calculate. But what you should get, if you plug in x equals 0, you're going to have 1 squared, which is 1, times -5, which is -5, plus 3, which is -2. But how you could have done that, it's really simple. That -5 tells me, well, when I go over 1, instead of just going down 1, I'm actually going to have to go down 5. That's how it gets narrower, because it's going up or down farther each time you go over 1. And there's a point. So I made a point at 0, -2. You could have figured that out 2 different ways. Like I said, you could have just looked at this and said, okay, it's negative, so I know it's opening down. And then it's a 5, so if I go over 1 from the vertex, I know I've got to go down 5 to get to my next point. Now that only works for the first point, keep in mind. After, if you go over 2 from the vertex, you can't just go down 10. That would be a straight line. This is a parabola, so it's going to go down a lot farther than that as you go out away from the vertex. Or you could have just plugged in 0 for x and calculated it to get -2 for y. Okay, so now I've done the graph of the parabola. I need to also do my axis of symmetry, so choose my line tool, make a line through, a vertical line through the vertex, make sure it is dashed or it'll be counted wrong. Click save here, and then I'll come check my answer. Good job, it says. The vertex is, well, that's the first thing we did. We found that the vertex was at -1, +3. Okay, and then the axis of symmetry, if you know the vertex, the axis of symmetry is just x equals the x value of the vertex, -1. Okay, I think that should probably be enough examples. You should be able to do all of these now. None of them are super complicated. I will say this last one here. Let me just pull that up real quick. There's a fraction in front of the x squared. Oh no! The only thing that should affect is when you're trying to figure out your second point for your parabola. Notice 3/2 in my example. Yours won't necessarily be 3/2, but mine is. 3/2 is greater than 1, so that should tell you it's going to be a little narrower. But all you got to do is plug in a value of x and figure out a second point to plot, and it's not too bad. I would advise you to choose an even number so that you can divide it by 2 and get a whole number, since the 3/2 is your multiplier. But okay, that should get you through Unit 3, Lesson 8. As always, email me with questions.